Hello everyone and welcome to today's session, Machine Learning and its categories, supervised and unsupervised. My name is Raghav from IIDST and I'll be guiding you through the foundational concepts of machine learning. What is machine learning? It's essentially a transformative branch of artificial intelligence, AI. That is, it falls under the category of AI. AI is a much broader subject, AI is a much broader domain, and machine learning is a part of the artificial intelligence domain. It has become a cornerstone of modern technology today. Machine learning powers everything from recommendation systems to fraud detection in banking and even self driving cars these days. In this session, we'll mainly explore what machine learning is, how it works. We're going to be exploring three major topics mainly. Firstly, what is machine learning and how it works, of course. Second, the topic is the two main types of machine learning which are used on a day to day basis today, supervised and unsupervised learning. The third topic is the real world applications and the advantages and challenges of machine learning. By the end of this presentation and the end of this video, you'll have a solid grasp of these concepts and their significance in today's tech driven world. So without further ado, let's get started. Okay, so the question arises, what exactly is machine learning? Why are we watching this video? Because we want to learn about machine learning, obviously, and machine learning is a branch of AI that focuses on building systems capable of learning and improving from data without explicit programming. Now, let me tell this to you, explain this to you very simply. What machine learning does is that in traditional computing, in traditional computer systems, we have programs based on conditions if else systems, such as if this condition happens, then do this. For example, let's say if this button is pressed, then do this action, etc, etc. But machine learning removes this. It says, okay, learn from the past, learn from what inputs you have been getting up until now, and perform actions yourself. You do not need any explicit input for performing new actions. You can perform them yourself. So, unlike traditional programming where we write specific rules and instructions, machine learning removes all of that. It enables a computer to learn patterns, trends, and relationships within data to arrive to predictions or decisions. So let's say, for example, consider spam filters in email systems. We all use mail and we all have a spam folder in mail systems. So what it does is, instead of manually defining every possible characteristic of spam emails, machine learning algorithms analyze large data sets of spam and non-spam emails to identify patterns that distinguish the two. What we're doing here essentially is, it's very simple. Let me break it down for you. There can be n number of cases of spam. Let's say you can have an advertising which you do not want, you can have a YouTube video recommendation which you do not want. There can be n number of cases here. So instead of defining each of these cases, that let's say if this is spam or not, we simply can train the machine learning algorithm from a data set of spam and non-spam mails, and based on that training it will automatically identify and it will learn a pattern, okay, that this is spam and this is not spam, and based on that it will do it by its own. We do not need to do anything. So as you can see, this here we have written, this learning process involves identifying trends, correlations, and insights hidden within large data sets, allowing for increased efficiency and accuracy over time. So this is very very important, increased efficiency and accuracy over time. So what we're doing here is that over the time, slowly and surely, it will get better. It allows itself to improve over time based on previous data, based on new data. As the data comes in real time, it improves. So the core principle is to allow computers to learn from experience rather than relying solely on predefined rules. Okay, learning from experience, just like a human learns, you can argue. That is why it's called machine learning. That is why it's a part of artificial intelligence. It's basically learning just like we humans do, right? So these three points are very important here: data driven, adaptive, and automated. Data driven, of course, ML algorithms are fundamentally data driven. They heavily rely on data. The more comprehensive, the better the data, the more representative it is, the better the algorithm's ability to understand, generalize, and make accurate predictions. So, where we source our data set from, how we source it, how we utilize it is all very important when we are, training a machine learning algorithm. Because if a student is learning from something, we must ensure that the resources that the student is learning from are very good, right? Then only the student will be able to learn very efficiently. So the same case applies here. We must ensure that the data is of high quality, it does not have any outliers, it does not have any bad values, so that our system is, great from the start. So data is very important in machine learning. Adaptive. Now, coming over to adaptive, these models are capable of adjusting their behavior and predictions as they're exposed to new data. So machine learning systems can improve themselves. They can get better with time, slowly and surely, as real-time data starts pouring in. So this adaptability becomes crucial in dynamic environments where data patterns and distributions may shift over time. This can be useful in high frequency trading firms and other various real time, real life scenarios where a lot of the data comes in very quickly and very fast, and the algorithms have to improve as the data comes in. So, adaptability is very crucial to machine learning systems. Through feedback loops and ongoing training, machine learning systems refine their internal parameters to better reflect the evolving nature of data. So through feedback loops, feedback basically means that they have a sort of mechanism in which they gauge how well their performance is, and based on that they have feedback loops wherein the data is trained again and again until it gets better eventually. We're not going much in depth right now on what feedback loops are. That was the very basic of it. But yes, adaptability is very, very crucial to machine learning. Coming on to automated, tasks that are too complex, time consuming, or error prone for humans, they can be automated with machine learning. For example, you could say language translation can be automated. We could automate image recognition, because these are things that humans can do just as easily. But for high volume of these tasks, we can prefer machine learning because it will make the process automated. By automating these tasks, ML enhances efficiency, reduces human error, and enables the processing of vast amounts of data at scale, unlocking insights otherwise inaccessible through manual analysis. There can be some key points, there can be some factors that the human eye can overlook, but machines will not overlook any such key points. A machine is trained to notice every pattern, every trend in the data. So that is why automation is very important in machine learning. This frees up human resources to focus on high level tasks requiring creativity and strategic thinking. This is very, very important. Machine learning as of right now is not very creative, as in we still give it commands and it does what we tell it to do. So it's not taking actions on its own. We're currently working on machine learning systems which can think creatively, which can have emotions, etc., so just like humans. But for now, we can use them to automate large tasks. We can use them to increase efficiency because they have the ability to learn. That's what they have right now. They can learn, they can improve over time. So we can use that to automate processes which require a lot of human labor, which require a lot of human intervention. So we can free up these low level tasks and use humans for higher level tasks such as creativity and strategic thinking. So in let's say in a company named X, we can have the all the low level work, all the manual work being automated via machine learning algorithms, and then the senior management, the upper management, what they can do is that they can make strategic decisions and other key important factors that require that make up the company's growth. So that is how machine learning can help us in our day-to-day lives, and this was the very core, the very basic of machine learning, what exactly it is, how it's data driven, how it's adaptive, and how it's automated, and how all three of these come together and combine as a whole to make life easy for us. Now we come to the types of machine learning. We have two types here: supervised and unsupervised learning. We'll be discussing all of these as we progress. Firstly, let's get started with supervised learning. So supervised learning works with labeled data sets. Each data point, now let me just briefly walk you through what a labeled data set is. each data point has an associated output or a label, which basically means that it allows the model to learn the relationship between input features and target outputs. Let me tell you this with an example. So imagine a data set of houses with information about their location, size, age, along with the selling prices. In this case, the house features are the input and the selling price is the output. Okay, so what the algorithm is doing here, that it's taking the features of the house. It could be a lot of things like in location, size, age of the house. These are the features, and then it trains them with the output, which is the selling price, because the output depends on the input, correct? Obviously, if a house is in a remote location, it will not be as expensive as a house in, let's say, a city such as New York. Houses in New York are very expensive. So based on that, we have a label on the data. We know, okay, this data is based in this house is based in New York. It has a size of this much square feet. It has an age of 5 to 10 years. So based on that, we can map it to the output, that okay, it can be this expensive, it would be this, because the price is the output. So that was supervised learning. That is what supervised learning is. The data is labeled. The algorithm knows where to map the data, where the input data is mapped to the labeled output data. So the key steps in in supervised learning are training, prediction, evaluation. So firstly, let's get started with what training is. Training the model, you'll be hearing this word a lot in machine learning domain. Training a model basically means that we are teaching the model on how to learn, on learning the features from the data and then applying those features in real world usage. So the model analyzes a labeled data set to identify patterns, and then it adjusts its parameters to minimize the difference between its predictions and the actual output. So we have a data where we have, let's say, a sheet where we have the actual output, and then based on what it learned, it has a predicted output. So it will try to minimize the gap between the predicted output and the actual output. So let's say if it predicted that a house in New York costs $500,000 and the actual cost is $600,000, it will try to minimize the value, it will try to close the gap. That is how it adapts. That is the adaptability, what we learned about here, this the adaptiveness. This is what it means. Adaptability is what training basically means. It will try to reduce the gap, it will learn again and again and again, it will adjust its internal parameters to minimize the difference between predicted and actual outputs. The training process iteratively refines the model's ability to accurately map inputs to outputs. Now comes to the now we come to the main part, prediction. Once trained, the model can predict the output for new unseen data points. As when we have the efficient, when we have the properly trained model, we can now use it to map. We can use to predict the output for unseen data points, because now we have tried to close the gap as much as possible. Now, if we have new input data, we have new input features, we can essentially map them to output features just based on our model, because it learned in the training section, it learned what the data was, it learned where to map x in the given certain input features to output features. So the accuracy of these predictions depend heavily on the quality and representativeness of the training data used, correct? Now evaluation. So after training, the model's performance is evaluated using metrics such as accuracy, precision, recall, and F1 score. These are all evaluation metrics: accuracy, precision, recall, and F1 score. These are used to gauge how accurate our machine learning model is. This evaluation helps to determine how well the model generalizes to unseen data and identifies areas for improvements. Basically, in simple words, it tells us how much the computer, how much the algorithm has closed the gap between predicted values and actual output. So techniques like cross validation are commonly employed to ensure robust and reliable evaluation. We have an example over here: predict house prices based on features like location, size, number of bedrooms, and age. Other examples include spam detection in emails, image classification, and medical diagnosis. So, to sum this entire page up, supervised learning trains a model on labeled data. Correct. We have input features labeled, we have an output feature where we want to map For example, if we take the house example again, we have age, location, number of bedrooms, it could be floor size, etc., etc., and then the output is the price of the house. So we'll train the model based on previous data, based on historical data of prices in that area, of house prices, and of all ranges in that area. And using that data, we'll try to predict the pricing for a new house. Let's say a new house has 2000 square feet, and the new house is uh, let's say a 2 3 bedroom house, and its location is Manhattan. So predict whether we'll try to predict whether what the cost of the house will be based on the model that we have trained. So that was supervised learning. Now there are mainly two types of categories. There are two types of algorithms mainly used in supervised learning. It's regression and it's classification. Now regression is used for continuous outputs. Continuous outputs, there are two types of outputs. There are continuous or categorical outputs, which are very popularly used. So continuous outputs are outputs which are always continuous in nature, like we can see by this line. For example, let's say house prices or stock prices, like we just discussed, and house price can fluctuate. It can go up, it can even go down sometimes. The house price can fluctuate with time to time. It's a continuous value. It's a line on the, it's a curve, sorry, it's a curve on the graph. So that's why we use regression over here. This is a polynomial regression model, by the way. The graph of a polynomial regression model will tell you what it is. Linear regression is very simple. It's a straight line relationship between input and output variables. So linear regression graph looks like this. Sorry. It's a straight line like this. Polynomial regression, you can see it's a curved line. And logistic regression has a binary output. It's used for classification tasks. So we can use this algorithm for classification tasks as well. Because it gives out a binary output. Linear regression is simple. It's a straight line. So the relationship is pretty stable. It's not that variable. In polynomial regression, the values can fluctuate a lot. So it's a curve like this. It's not a straight line. Okay. Now we come to classification. Classification predicts categorical outputs, such as we discussed earlier in the email system. It's a spam or not spam system. So in classification, we classify values into different sections. So let's say that we want to classify a mail, if it is a spam or not. So we'll not use regression over here, because regression is used for continuous data. This is used for categorical outputs. So we'll use a classification for putting it into various categories. So in classification, we have classes such as binary classification, multi-class classification, decision trees, and support vector machines. So what binary classification does is very simple. We can see that it predicts between two categories. Binary means two, 0 or 1, spam or not spam. So it predicts between two categories only. But if you want to use two or more categories, we can use multi-class classification. What it does is that it predicts among multiple categories. So for example, you want to have different types of fruit, you want to have different type of colors, you want to predict different types of, let's say, cars, even vehicles, anything which requires multiple classes, you can use multi-class classification for that. It predicts among multiple categories. After that comes decision trees. Decision trees are tree like structures that make decisions based on features. Now what this means is that it splits data based on feature value. So it creates a tree like model, like this. It creates something like this. It splits down data based on feature values. So if a data has, let's say, if a data has this feature, it will go here. If after that it has this feature, it will go here. Same like if it has this feature, it will go here, it will go here. So it classifies based on features. It splits data into based on features. Next comes support vector machines. Support vector machines separate data points using a hyperplane to classify them accurately. Now, a hyperplane essentially is an imaginary, of course, it's an imaginary plane, and the data points closest to the hyperplane are called support vectors. We'll discuss more on this in a later video. We'll go much into depth on support vector machines. For now, you need to know it that it's a hyperplane that separates data points into different categories. Now let's talk about unsupervised learning. So unlike supervised learning, unsupervised learning works with unlabeled data set where the output is unknown. So like we discussed in the previous supervised learning section, the houses of the prices of the houses were known to us. We knew that okay, if we have certain factors like location, age, floor size, etc., we can guess what the price was because we know what the prices of similar houses are. But here the output is unknown. We do not know where what the price of the houses are. We do not know anything about the output. But the goal here is to identify hidden patterns, structures, or relationships in a data. So let me tell you this by example. Think about customer segmentation in e-commerce. We all use e-commerce platforms such as Amazon, etc. So using unsupervised learning, companies can group customers based on purchasing behavior, helping them tailor marketing strategies for each segment. So let's say women and men will be attracted towards different things. There are different needs, there are different requirements. So based on that, we can gauge whether the person is a male or a female, and then we can put them in different segments, and then we can tailor-made advice give we can give tailor-made advice on to them based on their purchasing history, etc., etc. So it's very important for exploration, structure, and applications. What are these three? Exploration is basically helps to discover hidden patterns and relationships in data. A structure is that it can identify clusters, anomalies, and other structures in the data. And it's used for applications such as customer segmentation, anomaly detection, and dimensionality reduction. Now that we know what unsupervised learning is, let's move on to the types of unsupervised machine learning. The first one here is clustering. Clustering means what is clustering in basic English terms? Clustering means to group something, right? So let's say this is a cluster, this is a cluster, this is a cluster, and they have data points which are closely related inside them. So we can say that hey, if these data points are very close to each other, they must be having similar features to each other. So we can create a cluster out of them and we can group them. That is essentially what clustering means. We have certain types over here, which is k-means clustering, which let's say k-means clustering here divides data into k clusters. For example, grouping customers into high, medium, and low spenders, right? Hierarchical clustering creates a hierarchy of clusters based on similarity. So it builds a tree of clusters to help represent relationships. And density based clustering identifies clusters on the density of data points. So for example, if the data are very close, then that's a very dense region, so it will cluster them based on that. What we just discussed, this was essentially density based clustering, right? So now that we have discussed about all this, let's discuss about dimensionality reduction. So dimensionality reduction techniques reduce the number of variables in a data set while preserving important information. So in a data set, let's discuss about this for a while. In a data set, we can have a lot of variables, a lot of values, a lot of factors, but in our daily life, in our real world use case, we do not need all of them, right? Because then the machine learning model will just get confused. If you want to teach a student maths and wants to start from the beginning, you will not give them high, let's say university level maths if they're a school student, correct? You'll only give them the school syllabus. So that is dimensionality reduction. You reduced mathematics, the whole subject of mathematics, and you reduce it in such a way that only the school, only the part of this where the school mathematics is there which is the student is concerned with, only that is being delivered, only that is being taught to the student. So dimensionality reduction techniques reduce the number of variables in a data set while preserving important information. This is very important. The important information, the information which is relevant to the algorithm, is always preserved. The useless, the irrelevant points are removed. So principal component analysis is done, which finds the principal components, which principal component basically is another word for important information. It finds the main components, the information that we need, and it captures the most variance in the data. Linear discriminant analysis, LDA, it reduces dimensions while maximizing class separability. So it, what it does is that it reduces dimensions. So this is very simple to understand, is that it ensures that classes are separate, that is there are differences in various classes of data and they are more noticeable, and it reduces dimensions, that is it reduces extra layers, extra points which you do not need. And then there is TSNE, which is T distributed stochastic neighbor embedding. It visualizes high dimensional data in a lower dimensional space. So what it does is it converts high dimensional data and it converts them into a lower dimensional space. So that was dimensionality reduction for you. In total, unsupervised machine learning is widely used for anomaly detection, like identifying fraudulent transactions, and for data visualization, making larger data sets easier to interpret. Now we should understand the advantages and challenges of machine learning. So it offers powerful tools for analysis, prediction, and automation. However, it presents challenges that require careful consideration. So the advantages are automation, of course, which we discussed. It automates repetitive and complex tasks, saving time and reducing human errors. Accuracy. Accuracy is very important because ML models, what they do is that when trained with quality data, they can outperform humans in tasks like image recognition. Valuable insights. They can handle, they can give us valuable insights. They can handle a lot of data as well. So they are very scalable, in fact, per se, because ML handles vast data sets. Obviously, humans cannot gauge such large data sets, and it uncovers patterns and insights beyond manual analysis. However, in machine learning too, there lie big challenges. The data can be biased. That is, if the data is biased towards a certain value, if the data is biased towards a certain section, then that will not give us an accurate output, because then the model will also be biased towards a certain category, towards a certain data point. You that does not make it a very promising outlook. So there should be no bias in data. Modern interpretability. Many advanced models like neural networks are black boxes. Black boxes means you can only look at the outside, you cannot understand how they work because they are very complicated. So it's hard to understand how they make decisions if you are not a very advanced learner here. Ethical concerns, of course. We need to have legal structures on how AI and ML are operated. We should prevent misuse of AI. We should have privacy concerns as well, because AI, of course, trains on a lot of data. So there should be ethical and legal structures that define where the data comes from and how it is used. So these are challenges of data. Future, of course, is very bright. Continuous R&D are expanding the capabilities of ML. Every new year or so, a new paper is published which boosts the research, which boosts the development of AI and ML algorithms, and the future is, of course, very bright. Some real world applications of machine learning. It has, of course, impacted every day of our life. We all use chat GPT in some way or the other, and that is, of course, machine learning at its best in our day-to-day use. That is honestly the best example that one can have of how machine learning is transforming our day-to-day life. But here are some more in case you did not know. Image recognition in healthcare. Analyzing medical images for disease detection, assisting in robotic surgery, and improving diagnostic accuracy. So it's analyzing a lot of images, it's analyzing x-rays, MRIs, etc., and it detects diseases such as cancer, etc. It's been machine learning algorithms to develop are being developed which detect cancer in patients at a very early stage. It assists in robotic surgery and improves diagnostic accuracy. NLP in finance. Now, finance sector is something which depends a lot on news and trends and market changes. So it analyzes all of that and it predicts market trends, which automate which ultimately lead to a higher profit for, let's say, traders and all. It automates customer service through chatbots and detects fraud activities in transactions. Based on, of course, these are all based on label data set. If we know how what fraud activities look like, then only we can train the model to detect fraudulent activities. Third is recommendation systems in e-commerce. Now we all use Amazon, we all use various other platforms such as Myntra, Flipkart, etc. etc. So we all know that if we buy a shoe, it shows us socks. If we buy a pen, it shows us a notebook. How it does that is that it uses the user browsing history and purchase behavior, and it optimizes marketing campaigns by targeting specific customer segments and increases customer engagement via personalized content. Predictive analytics in self-driving cars. Teslas are all the hype these days, and they have the ability to drive themselves. How this happens is that it takes in real time data, it predicts driver behavior and road conditions to enhance safety, and makes decisions about speed and lane changes in autonomous driving systems. It has the ability to make decisions by itself because it can predict what the driver behavior will be, what the road conditions are, what cars are ahead of it, etc., etc., many such factors. It takes it all in, it computes them through using the ML algorithms it has been trained on, and then it assists in safety and makes driving a better experience for everybody. And that was it, guys. Thank you for watching this video. Machine learning, I'll wrap all this up very shortly. Machine learning is essentially a revolutionary technology driving change across sectors. Understanding supervised and unsupervised learning is essential to appreciating its capabilities and potentials. Thank you for joining this session. Feel free to reach out with the questions, and I hope this has been an insightful journey into the world of machine learning. Thank you so much.